Today, most of the Fortune 500 companies uses Kafka as the central platform for managing the streaming data of their organization. Organizations such as LinkedIn, Microsoft and Netflix all processes over more than 1 trillion messages in a day over Kafka. So Kafka is used by companies for creating new products, responding to customer and make business decisions in real time. It is fast, scalable and fault tolerant messaging system which is used for performing real-time analytics. So in today's session, we'll learn Apache Kafka comprehensively. Before going ahead, do subscribe our YouTube channel and press the bell icon so that you never miss out our upcoming content. Also, if you want to become a certified professional, I would like to suggest you this Apache Kafka certification and training provided by Intellipaat. So let's have a glance at the agenda. We'll start off by understanding how Kafka came into existence. After that, we'll see what is Apache Kafka. Then we'll look at its architecture and see how to set up Kafka cluster. After that, we'll understand what is Spak and look at its features. Then we'll see the different components of Spak. Finally, we'll have a demo to first integrate Spak streaming with Apache Kafka, then integrate Flume with Apache Kafka. You can put down all your queries in the comment section and we would love to help you out there. So without any delay, let's start off with the class.
So let's understand the need of Kafka. The current day industry generates a lot of real-time data which needs to be processed in real time. So let me explain this to you with the help of this diagram. These days, organizations have multiple servers at front end and back end like web or application server for hosting website or application. Now all of the servers will want to communicate with database server and thus will have multiple data pipelines connecting all of them to the database servers. So you can see that the data pipelines are getting more complex with the increase in number of systems. And adding a new system or server requires more data pipelines which will make the data flow complicated. And managing these data pipelines becomes very difficult as each data pipeline has its own set of requirements. So adding some pipelines or removing some pipelines is difficult in such case. So this is where Kafka comes in with all the right answers to the above problems. So Kafka basically decouples the pipelines. So as you can see, there is a cluster in the center and then we have consumers which can place a request and there are producers which send messages. So the producers send messages to the cluster from where the consumers can fetch them. So this way, Apache Kafka reduces the complexity of data pipelines and makes communication between systems simpler and manageable. And it is also easy to establish remote communication and send data across a network. So you can establish an asynchronous communication and send messages. Kafka also ensures that the communication is extremely reliable. So now let's understand Apache Kafka in detail. So Apache Kafka is an open source distributed publish-subscribe messaging system which manages and maintains the real-time stream of data from different applications, websites and so on. So Apache Kafka originated at LinkedIn and later became an open source Apache project in 2011. Then in 2012, it became first class Apache project. So Kafka is written in Scala and Java and it is fast, scalable, durable, fault tolerant and distributed by design.
Just a quick info guys, if you want to become a certified professional in Apache Kafka, then Intellipaat offers Apache Kafka certification and training course. For further details, you can check the description below. Now let's continue with the session.
Now let's understand about various components of Kafka. So we have brokers, which are basically the servers that manage and mediate the conversation between two different systems. Brokers are responsible for the delivery of messages to the right party. Then we have messages, which could be of any format such as string, JSON, Avro, and so on. After that, we have topics. In Kafka, all the messages are maintained in what we call topics. These messages are stored, published and organized in Kafka topics. And then we have clusters. In Apache Kafka, more than one broker, that is, a set of servers, is collectively known as Kafka cluster. Now let's look at producers. So producers are the processes that publish the data or messages to one or more topics. So these are basically the source of data stream in Kafka. Then we have consumers. Consumers are the processes that read and process the data from topics by subscribing to one or more topics in the Kafka cluster. And finally, we have partitions. Every broker holds few partitions, and each partition can either be a leader or a replica for a topic. All writes and reads to a topic go via the leader, and the leader is responsible for updating replicas with new data. If the leader fails, the replica takes over as the new leader. So now it's time to understand about Apache Kafka's architecture. So the producers will send message to a topic at regular intervals. Now, brokers store the messages in the partitions configured for that particular topic. And if a producer sends two messages and there exist two partitions, Kafka will store one message in the first partition and the second message in the second partition. Now, consumer always subscribes to a specific topic. On receiving the message, consumer sends an acknowledgement to the broker. On receiving the acknowledgement, the offset is changed to the new value and is updated in the zookeeper. Now let's go ahead and check out few interesting facts about the Kafka producer. So producers send records or messages to topics. Producers will also select to which partition a message is to be sent per each topic. The producer could implement priority systems, which is based on sending the records to certain partitions depending on the priority of the record. So producers send records to a partition based on the records key. So they don't wait for acknowledgements from the broker and send messages as fast as the broker can handle. Now let's look at brokers. So the cluster typically consists of multiple brokers to maintain load balance. The broker, on receiving messages from the producer, assigns offsets to them and commits the messages to storage on disk. And the service consumers by responding to fetch requests from partitions. So one broker instance can handle thousands of reads, writes per second and terabytes of messages. So if backup is a point of concern for you, then let me tell you that backups of topic partitions are present in multiple brokers. So if a broker goes down, one of the broker containing the backup partitions would be elected as a leader for the respective partitions. Now let's look at messages. So messages in Kafka are categorized into topics, and these topics are broken down into a number of partitions. Reading messages can either be done in order from beginning to end, and we can also skip or rewind to any point in partition by providing an offset value. So offset value is nothing but the sequential ID provided to the messages. So these partitions provide redundancy and scalability. So partitions can be hosted on a different server, meaning that a single topic can be scaled horizontally across multiple servers, thus enhancing the performance. So the figure over here shows a topic with 4 partitions, with writes being appended to the end of each partition. Here a record is stored on a partition either by record key if the key is present or by round robin if the key is missing. So here you can see there are multiple brokers and there is a topic which has 4 partitions. So each partition has its own ID. The ID of a replica is same as the ID of the broker that hosts it. And for each partition, Kafka will elect one broker as the leader. Supposing the replication factor of a topic is set to 3, then Kafka will create 3 identical replicas of each partition and place those replicas on available brokers in the cluster. Now let's look at the working of consumers. So the consumer can subscribe to one or more topics and reads the messages in the order they were produced. It keeps track of the messages it has already consumed by keeping the track of the offset of messages. So messages with same key basically arrive at the same consumer. So the consumers work as part of a consumer group, which is one or more consumers that work together to consume a topic. The group assures that each partition is consumed by only one member. So as the figure shows, there are 3 consumers in a single group consuming a topic. and two consumers are working on one partition each, while the third consumer is working on two partitions. Now let's look at the Zookeeper. So Zookeeper is an open source Apache project that provides centralized infrastructure and services that enable synchronization across an Apache Hadoop cluster. So developed originally at Yahoo, Zookeeper facilitates synchronization among the process by maintaining a status on Zookeeper servers that stores information in local log files. And these Zookeeper servers are capable of supporting a large Hadoop cluster. So Kafka brokers coordinate with each other using Zookeeper. Producers and consumers are notified by the Zookeeper service about the presence of new broker in the system or about the failure of the broker in the system. So this is why Zookeeper is really important for Kafka.
Just a quick info guys, if you want to become a certified professional in Apache Kafka, then Intellipaat offers Apache Kafka certification and training course. For further details, you can check the description below. Now let's continue with the session.
Now let me help you in understanding a single broker setup configuration in Kafka with the help of a demo. So for this demo, you would need to have Java, Kafka and Zookeeper in your system already. So your first step would be to open the terminal and start the Zookeeper and the Kafka broker. So this is the command to start the Zookeeper, Zookeeper server start.sh. After that, I'll give the path Kafka config zookeeper.properties. So we are starting Zookeeper now. What I'll do is I'll duplicate the session, and in this new session I will start Kafka now. And this is the command to start Kafka, Kafka server start.sh, and this is the path Kafka config server.properties. I'll hit on enter, and we are starting Kafka now. Now I'll open another terminal. Now let me type GPS to check if Kafka and Zookeeper are running or not. Right, so quorum peer means, so this tells us that Zookeeper has started and Kafka tells us that Kafka has also started. Alright, so now since we have started Kafka and Zookeeper, it's time to create the Kafka topic. So this is the command to create Kafka topic, Kafka topics.sh, and then we'll give double hyphen and given the command create. After that we'll type Zookeeper and given the port number over here, localhost 2181, and then we'll set the replication factor, which is 1. After that we'll give the number of partitions, which is 1, and then we'll give topic and give the name of the topic. So I'm setting the name of the topic to be my topic 1. Right, so we see that we have successfully created the topic my topic 1. So now it's time to start the producer to send some messages. And this is the command to start the producer, Kafka console producer.sh. We'll give double hyphen broker list, and then we'll set the local host and given the port number. After that we'll give topic and give the name of the topic, which is my topic 1. I'll hit on enter, and over here we can give the set of messages. So let me just type hi, how are you? Right, again I'll duplicate the session. And this is the command to start the consumer, Kafka console consumer.sh, bootstrap server, localhost, and then I'll give the port number. After that topic and give the name of the topic and then type from beginning. I'll hit on enter. Right, so we see that the messages which we had sent from the producer, we get them in the consumer. Now let's say I type something else over here. Sparta hello world. Now let me open the consumer and see, right? So Sparta hello world. Let me write some more messages through the producer. So I'll just type some random words over here. Random words. And again we see that we've got those messages in the consumer. Now let us understand about Spak briefly. So Spak is a cluster computing framework for real-time processing. It was introduced as Hadoop's sub-project in the UC Berkeley R&D lab in the year 2009 and became open source in 2010 and was finally donated to Apache Software Foundation in the year 2013. So Spak provides an interface for programming all the clusters with implicit data parallelism and fault tolerance. Now let us look at some of the features of Spark. So Spark provides real-time computation and low latency because of in-memory computation. And Spark is 100 times faster for large-scale data processing. And Spark is also polyglot. So you can write Spark applications in multiple languages such as Java, Scala, Python, R, and SQL. Spark also has powerful caching. So it has simple programming layer which provides powerful caching and disk persistence capabilities. And Spark also provides multiple deployment modes. So it can be deployed through Mesos, Hadoop via Yarn, or Spark's own cluster manager. Now, Spark's impact was such that from small startups to Fortune 500s, almost every single company started adopting Apache Spark to build, scale, and innovate their big data applications. Industries like media, healthcare, finance, e-commerce, and travel, almost every single industry is using Spark intensively. So now let us go ahead and understand the concepts of RDDs in Spark. So when it comes to processing the data over multiple jobs, we need to reuse and share the data, which can be achieved through in-memory data sharing, which is actually faster than network and disk sharing. This is where RDDs come in to help us with in-memory data sharing. So RDD stands for Resilient Distributed Dataset, and it is the fundamental data structure of Apache Spark. So by resilient, I mean fault tolerant, as it can recompute missing or damaged partitions in case of a node failure with the help of RDD lineage graph. And it is distributed since data resides on multiple nodes. And finally, dataset represents records of the data you work with. So the user can load the dataset externally, which can be either JSON file, CSV file, text file, or a database. So now let us understand the various components of Spark ecosystem. Let me start with Spark core component, which is the most vital component of Spark ecosystem. It is responsible for basic IO functions, scheduling, monitoring, and so on. So you can say that the entire Spark ecosystem is built on top of it. Then we have different deployment modes. So Spark can be deployed through Hadoop via Yarn, Mesos, or Spark's own cluster manager. Then we have different libraries. So the Spark ecosystem library is composed of Spark SQL, MLlib, GraphX, and streaming. So Spark SQL helps us in performing queries on data and store data using SQL-like queries. Then we have MLlib. The Spark machine learning library eases the deployment and development of scalable machine learning pipelines like summary statistics, correlation, feature extraction, and many others. And GraphX component of Spark helps the data scientists to work with graphs and non-graph sources to achieve flexibility and resilience in graph construction and transformation. Then we finally have the Spark streaming component, which allows us to perform batch processing and streaming of data in the applications. Coming to the programming languages, Spark can be implemented in Scala, R, Python, and Java. However, Scala is the widely used language for Spark. And finally, we can store data over HDFS, local file system, and cloud. It also supports SQL and NoSQL databases. So now you might have got a brief idea about Spark components. But let us discuss streaming in detail, as we'll be performing a demo on Kafka Spark streaming towards the end of our session. So data streaming is a technique for transferring data so that it can be processed as a steady and continuous stream. A data stream is an unbounded sequence of data arriving continuously. There are so many users out there using various streaming sources like YouTube, Netflix, Facebook, and Twitter. And all these sources produce live streams of data. Thus, streaming technologies are becoming increasingly important with the growth of the internet. So Spark streaming is used for processing real-time streaming data. It enables high throughput and fault-tolerant stream processing of live data streams. And with Spark streaming, we can perform RDD transformations on mini batches of data. So the fundamental stream unit here is known as D-stream, which is basically a series of RDDs to process the real-time data. So now that you understood what exactly Spark streaming is, let's have a look at some of the features of Spark streaming. So Spark streaming is scalable. Let's say you start processing with a single node, but then with the increase of data, you can add more nodes as and when required. Spark streaming is also very fast and helps in achieving low latency. Another feature of Spark streaming is that it provides fault tolerance. That is, if there is any failure or error during streaming process, it can be handled without any loss of data. Spark streaming can be easily integrated with both batch processing and real-time processing. So now let me brief you about how Spark streaming works. So as you can see here in the diagram, Spark streaming receives live input data streams from various sources. It divides the data into multiple batches, which are then processed by the Spark engine and generates the final stream of results in batches. So now we'll implement a demo on how to integrate Kafka with Spark streaming. So in this demo, we are going to fetch data from Kafka topic to our Spark app. So let me actually show you guys the folder where our Spark application is present. So I have created a folder with the name Kafka Spark Streaming, and the entire Spark application would be in this folder. So let me hit ls and let's see what do we have. So we have build.sbt over here, which basically has all the dependencies to run the code and build the jar file. And inside this src folder, we've got the code file for the Spark application. So let me go into this src folder. I'll hit ls. So inside this we have the main folder. Again, let me go inside that, cd main, and inside the main folder we have the Scala folder. So I'll go inside that too, cd Scala, and inside this we finally have our Scala program, Kafka r.scala. So let me open it, vi Kafka r.scala. So this is our program for the Spark application, right? And over here in the program, if you can see, I have given the name of the topic to be my test. So later on, when I'm creating a topic, I would have to name the topic to be my test. So now that we've seen this folder which has all the Spark code, let me go ahead and start Zookeeper and Kafka. So now let me put in the command to start Zookeeper. So it'll be Zookeeper server start.sh, and then I'll give the path kafka/config/zookeeper.properties. So we are starting Zookeeper now. I'll duplicate the session and I'll also start Kafka. So this will be the command to start Kafka, Kafka server start.sh, and this is the path kafka/config/server.properties. I'll hit enter and we see that Kafka is also starting. Now again, let me duplicate the session. So let me type GPS to see if Kafka and Zookeeper have started or not. Right, so we see that quorum peer main, this tells us that Zookeeper has started, and we have Kafka over here which tells us that Kafka also has started. So now it's time to create a topic with the same name which we had provided in the program. Right, so this is the command to create the topic, Kafka topics.sh. I'll give the create command and then I'll type Zookeeper. After that I'll give localhost and then set the port number. And then I'll give the replication factor, which is 1. After that, I'll give the number of partitions, which is also 1. After that, I'll type topic and give the name of the topic, which is my test. So we have successfully created this topic, my test. Now it's time to create the producer to pass on some messages. And this is the command to start the producer, Kafka console producer.sh, broker list, and then we'll type localhost and give the port number. After that, we'll type topic and give the name of the topic, which is my test. Alright, so we have also started the producer, and then we can start giving in the messages. Hi, how are you? So now what I'll do is I'll create a duplicate session, and in that duplicate session, I will compile and run the Spark session. So let me go to the Kafka Spark streaming directory, cd Kafka Spark streaming. So let me see what do we have over here. So we have the build.sbt file, libmanage, and the src file. So now I'll compile the sbt file. So let me just type sbt compile. Right, so we see that done compiling. This means that we have successfully compiled the .sbt file. Now let's also run this. Let me give in the command sbt run. Great, so we have successfully started this session. So now what I'll do is I'll pass in some messages through the producer and we'll get all of those messages in the Spark session with real time over here. Right, so Sparta, this is Sparta. Right, so we see that these messages which I'm sending through the producer, we get this in the Spark session over here. Sparta, this is Sparta. Again, let me also send some random messages. Right, so we get all of these random message 1, 2 and 3 over here. So this is Spark Kafka integration, and we get this in the session over here. This is Spark Kafka integration. Right guys, so this is how we can integrate Spark with Kafka.
Hi everyone, welcome to the session of Kafka. In today's agenda, we will see what is Kafka integration and what is the need of this Kafka integration. After that, we will have a small introduction with Apache Flume. We will simply set up a standalone Flume node and we'll have a small demonstration of Flume. And after that, we will integrate Flume and Kafka so that Kafka will generate some messages. Those messages will pass through Flume and finally get loaded into HDFS. So let us start with what is Kafka integration. Kafka integration is nothing but to combine the features of Kafka with any another distributed system so that we can enhance and get the functionality of two distributed systems at a time. For example, we can integrate our Kafka with Flume, and it is the easiest way to load your data from Kafka as a source and then load that into Hadoop. Apart from that, you may also get a need to process your data in real time. In that case, we will use Kafka with Spark and Storm. Kafka will produce the messages. Those messages will go to Spark or Storm. There the real-time analysis will happen, and finally we will send that processed data to some third-party tool. You can say the third-party tool can be Hadoop or any another NoSQL database. Now, let us have a small introduction to Apache Flume. Apache Flume is a distributed, reliable, easy to use, flexible tool which helps achieving fast data loading of huge data sets from various sources to the sinks by the mean of a channel. This means that we are going to have a source, you can say a file, which will pass through a channel. The example of channel is a memory, and finally that data will be stored into sink. The example of sink can be anything like your HDFS or any another file or any other directory. To get this done, we will run a service called Flume Agent, which is nothing but a JVM which internally handles the three components of Flume. We do not need to do anything else. We will simply put our tarball to some node and we will run the Flume agent, which will have three inbuilt components that are sources, sinks and channels, and we will completely process our data from these three components. Now, as I said, the three components are sources, sinks and channels. Per Flume agent, you can have multiple sources, multiple sinks and multiple channels. So what are sources? The process which will produce the events. The examples are Netcat source, Avro source, HTTP source. It can be anything. It can be a file from where the data is continuously being updated and you need to move that data from that particular file to another location. Sinks, which receives the events. It can be logger sync, which means that if we want to display the fetch results and fetch events on the console itself, then we will use logger sync. Then HDFS event sync, which will be used when you want to store your data into HDFS, and rolling file sync means you are going to store the data in a file which is continuously getting updated and rolling over after a particular time or after a particular size. Channels, which connects sources and sinks. The examples are memory channel, the JDBC channel, the disk channel, or you can say the file channel. At the bottom of this PPT, you can see we are generating the data from web servers, which will directly go to some source, okay, pass through a channel, say memory, and then finally it will pass through the sink and get stored into HDFS. So the Flume agent will consist of these three components: source, channel, and sink. Now, what is an event? So whatever the messages that are being generated from the source, for example, say web server, which they all will be treated as events. You can simply say this is a message, and in terms of Flume, we will call it events. So it is nothing but a unit of data which can be anything like text, image, Avro file, etc. Data from the source to sinks will flow as an event. When we will do the demonstration, I will show you on the Flume agent, you can see event generated. And finally, the node defined size. We can have the event of any size. The size will be totally depend upon the channel's size. For example, if we are using in-memory channel and we have a fixed amount for that JVM, like say 2 gigs, so in that case we will simply generate the events till 2 gigs, or we can say the 80% of 2 gigs, and then after that these data will be synced to the disk or the any another source. Now, understanding the configuration. So before running the Flume agent, we will simply have to set up the conf property, which will be present at conf directory of Apache Flume, and its name will be flume-conf.properties. This property file will be used when you run your Flume agent. You can simply customize this as well. Say you just created a file with name exercise1.conf, so you can simply use that when you run your Flume agent. In that file, we will simply define what is the agent name, what is the source name, what is the sink name, what is the channel name, and apart from that, we will define some properties of these three components of Flume. Let us have a sample conf file, and I will explain what are the different components we do have here. So on the screen you can see the first one is name components, which means that we are naming our Flume components. In here, A1 is our agent, so it is the agent name, and the three components, sources, sinks, and channels, we are providing some names to them. So for sources we have the name source1, for sinks we have the name sink1, for channels we have the name channel1. After that, you can see the configure source. We are configuring this source1 now. A1.sources.source1, that is taken from here only, and dot type, we will define the type. What is the type from where we are getting the data? It can be, for example, it can be netcat, which is nothing but a server which will listen to some of the port and produce some data. The next one is to define the channel of this source, how we will process that data. So here it is a1.sources.source1.channels is equal to channel1. Channel1 is this thing, the name of our channel. Now configure the sink. a1.sinks.sink1. This we have taken from here only. a1.sinks, and its name is sink1. So we have taken this from here only. Dot type, we will provide the type. What is the type of sink? It can be HDFS, or it can be a simple file, or any NoSQL database like Couchbase, Cassandra, HBase, anything. We will define the channel for this sink as well. a1.sinks.sink1.channel is equal to channel1, which is the name of our channel. And finally, we will configure the channel. The type of the channel, In our case, we will be using in-memory channel. Okay. So this was how a sample configuration file will look like. Now, to set up your Apache Flume, you simply need to download that from Apache's website, or you can simply wget this at your Linux machine. I have given the path here, so you can simply use that. After that, you place that onto your Linux machine. Simply untar this Apache Flume starboard and then set the Java home and Flume home in .bashrc file. Let us complete this part on the Linux machine first. Okay, this is my Linux machine. Let me change the font first. Okay, so I have already downloaded the Apache Flume tarball here. I will simply untar this. Okay, I got this file, this directory, sorry. I'm simply moving this, I'm simply renaming this for our convenience, so that whenever we want to change the directory to Apache Flume, we can simply type a simple name instead of this Apache-Flume-1.6.0.bin. Okay, moving Apache bin to simply Flume. Okay, this is our Flume directory that we got from untarring the tarball. Inside that you can see an important directory, that is bin, where all these scripts will be there, and the second important directory is conf, where the actual configuration files will be present. We can customize our configuration for our Flume agent and place that customized configuration file into this directory. Let us have a look what is there inside this conf directory. You can set the log4j environments, and this is the property that the file that I was talking about, flume-conf.properties. Okay, so when we will do a demonstration, we will create our own conf file and place that into this place. Okay, after that, let us set the Flume home and Java home in bashrc file. So I have done that already. You can see this is my Flume home and this is my Java home. You can simply set both of these things, save that, run a command so that the Linux machine come to know we have some new changes in bashrc file. Okay, till now we have just get the tarball of Flume and untar that and set up the environmental variables. Let us move to the slides now. Let us do one small exercise. What we will do, we will generate some data using netcat, okay, which is nothing but a server which will listen at some port, and we can simply type our message there. The same messages will pass through the memory the memory channel and get stored to some sink location. So in our case, we will use the console itself as a sink of Flume. So we will see all the messages on the console itself. We will do the configuration changes which will define the parameters for all three Flume components. Okay. After setting the parameters in that configuration file, consider we will create a one configuration file, that is exercise1.conf. Inside that we will define the three components like sources, agents and channels for Apache Flume. Okay, and after that we will simply run the Flume agent. In the next step, we will generate the messages using netstat and finally check the same messages events at the Flume agent console. This is what we are going to do now. Okay, first of all, let us go to the Linux machine. I have already created one file, that is exercise1.conf. I will explain what exactly the configuration we have explained here. So at the first place you can see configuring components. We have an agent and its name is A1, and the Flume components like sources, channels and sinks. We are giving some names to them. Like our source's name is source1, channel's name is channel1, sink's name is sink1. Now we will configure the source from where the data will be generated. In this case, we need to define the type. Okay, a1 dot sources dot source1. This we have taken from here only. After that, we will simply type dot type. What is the type of the source? We are generating data from netcat, so we just simply write here netcat. What is the channel? Channel, we are going to use this. The channel name is channel1, so we simply typed it here. Now we need to type the IP of netcat server. This is our local server, so I have pasted my local IP here, and the port that we are going to use, and the port is, you can use any port here. Now configuring the channel. The type of channel is memory, the capacity is 10,000 bytes, and the transaction capacity means is 1000 bytes. Means whenever we will have the data of 1000 bytes, that data will be persisted to the sink channel. The sink, or in our case the sink is the console only, so in that case the data will simply keep rolling over the console. Now configuring sink. What is the sink? What is the type of sink? Logger. Logger means that we are going to simply store the sources messages or the sources events on the console itself, nowhere else. What is the channel we are going to use? Channel 1 that we defined here. So this is a simple configuration for our exercise. Okay, you can simply use this exercise 1.conf from here also, or you can simply put this at the Flume's conf directory. I'm putting this into Flume's conf directory. Okay, let us move to the slides. In the slide you can see I have pasted the screenshot for exercise 1.conf, and I have defined and highlighted important things here. Okay, these are the same things that I just explained, so I'm moving ahead. Now what is the task? We will need a Flume agent providing the configuration file to it. Okay, we will use the name of the agent that we defined in our exercise 1.conf, and finally we want flume.root.logger is equal to info console. I want all the results on the console itself. Whatever Flume is doing, I need to see all that information on the console. So in our case, what we will do, we will run the Flume ng, which is our agent. We will give the process name is agent -c, it will tell us where the configuration directory is. So we are going to use conf directory of Flume. -f, what is the configuration file? We are going to use exercise 1.conf here. What is the name of the agent that we defined in exercise 1.conf? It is A1. And finally, we want all the results on the console. Okay, let us run this now. I'm going to simply take this and run it here. Okay, so our Flume agent is running. It is displaying whatever it is doing on the console itself. As it starts, let me open another window. I have already opened that, where we will run the netcat server. Okay, so before we start generating messages, let us see what the Flume agent has done till now. You can see starting channel, and the channel name is channel 1. Okay, after that you can see channel name channel 1 started. Now it is saying starting sink. Sink 1 was the name of our sink. Starting source. Source 1 was the name of our source. Okay, it has started whatever we have given in the configuration file. Now it's time to generate messages via netcat server. The command is netcat, then the IP name. Let me check the IP name here that we gave in our exercise 1.conf. Hostname -i to get the IP. This is my IP. I will simply run netcat IP, and the port that I used in the config in the exercise 1.conf, I use 4444. Oh, sorry, I think we missed something. Just let me check the what was the correct command here in our configurations. Cat exercise 1.conf. Okay, the actual command is nc, not ncat. Okay, nc, the IP and the port. Okay, now our local server is running. We will simply type some messages here, and the same messages will go through the memory channel and will be displayed on the Flume agent console. Okay, now I am typing some messages here. This is my first event. Okay, it means the message has passed through the in-memory channel, and we should see the same message on Flume agent. Let us check this on the Flume window. You can see Flume generated an event. This is the ASCII code, and this is the actual message. Okay, let us generate some more messages. This is my second message or event. We are testing Flume, and the same messages we should see on the Apache agent console window. You can see here are the messages. This is my second message, and we are testing Flume. Okay, so on the console it will simply it will not show the complete message, but it is continuously storing all the messages here. So this is how we can test our setup and test our Flume agent. Okay, so I'm just closing this now, and I'm closing this Flume agent as well. I need to kill this. So now we have tested how we can set up the Flume agent, and then can run a simple demonstration to check if our messages are being generated properly and they are being passed from the memory channel to the sink. Let us move ahead with the slides now. Okay, we are done till here. We have generated some events using nc command, giving the IP and port. After that, we validated the same messages we were generating at netcat, and we were getting the same messages on the Flume agent console. Now it's time to integrate our Kafka with Apache Flume. We can simply take Kafka as a source, or we can use Kafka as a channel, and we can also use Kafka as a sink. In today's session, we are going to simply use Kafka as a source. We will generate some messages via Kafka console producer, and those messages will pass through in-memory channel and finally will be stored to sink. Okay, in our case the sink will be HDFS. We are going to load data into HDFS from Kafka's producers. Okay, for that what we actually need, we should have Kafka up and running. We should have Hadoop services up and running so that we can store our data into Hadoop, and then we will run the Flume agent after preparing one configuration files that will be used while we run the Flume agent. And this configuration file will contain all the information about sink, about in-memory channel, about the sources, which is Kafka in our case. So let us first start the Hadoop services and Kafka services. On this PPT, I have mentioned how you can start the Kafka services. So before starting Kafka, you need to start Zookeeper. Then you can start Kafka server and then create a test topic so that we can use that topic as a source. Whatever data will be produced in that topic, that will be passed through Flume to HDFS. Okay, let us start the services first. I have a small script services.sh which is doing nothing but starting name node, data node, resource manager, node manager and history server. I am running this. It is starting name node, now data node, now resource manager, node manager and finally the history. We can simply put JPS to check if all services are up and running. So all processes are up. So initially the name node machine will be in safe mode. So I'm going to enter a command that will take name node out of safe mode. Okay, so now our Hadoop is ready. We can simply write our data to Hadoop. Now it's time to run Kafka. So before that we need to run Zookeeper. So this is the command. I'm going to run this in background. Zookeeper -server -start.sh and we are passing the using the default Zookeeper properties from Kafka itself. I pressed enter. And now I will start Kafka server as well. Okay, this is the command which is present at Kafka's bin directory, Kafka -server -start.sh. We are passing the property file here, running this in background. Now you can simply do JPS and you can see Kafka is also running and the Zookeeper service is also running. Now we will create one sample topic in Kafka so that we can use that topic to generate some messages and then pass those messages to Flume. The command is okay, so this is Kafka Flume. I am giving the topic name as Kafka Flume. I am creating this. Okay, create a topic Kafka-Flume. So we have started Hadoop services, Kafka services, and we have created one new topic named Kafka-Flume. We will use this topic to produce some messages and those messages will be stored in this topic. Okay. Now it's time to create a Flume agent configuration file that will include all the details regarding your source, your sink and your channel. I have already prepared one exercise file that I have named it exercise 2. Okay, so let me explain what are the different components that I have used here. First one is exactly similar that we used in our exercise 1. We have some agent name that is A1 and we have given the names to all three Apache Flume components. Source's name is source1, channel's name is channel1, sink's name is sink1. First of all, we are configuring source. In our case, the source is Kafka. So the type will be this one, org.apache.flume.source.kafka.kafka source. In previous example, it was simply netcat. We also need to provide the details that are related to Kafka so that we can properly fetch our data from Kafka topic to Flume. We need to give the Zookeeper details, Zookeeper connect. In our case, it is running on localhost and the port used is 2181. We need to give the topic name, which is Kafka Flume in our case. So I will simply update this file. Okay, so in our case, The topic was Kafka-Flume. We can simply give a Flume ID, sorry, a group ID. We can give any name here. Then the channel is channel 1 that we have defined here already. These are some of the interpreter and optional commands that you can use, because I am going to store my data with date in HDFS. That's why I have used these types. Okay, the interpreter types. Now the second thing is configuring channel. We are using in-memory channel. We have given the capacity and transaction capacity as well, just like we did this in the exercise 1. Then we will configure the sync. Earlier our sync was the console. This time we are going to store our data into HDFS. Channel use is channel 1. We have defined this here. And we are going to store this to this HDFS path. Temp. Then topic will be created whatever we have given here. For example, Kafka-Flume directory will be created in HDFS, and the date. We are going to store the data date wise. Apart from that, we have given some optional parameters as well. Whenever roll interval is equal to 5 seconds. Number of seconds to wait before rolling current file. If we need to create a new file, it will wait for 5 seconds. Roll size after size of 1 KB file, we will be getting a new file. Roll count tens. If we generated 10 events to a particular file, we will get a new file after that. The last is file type is data stream. When you will move data from Kafka source to HDFS via Flume, the first thing is that it will generate the data in sky format only. So to get the data in text format, you need to define this data stream. Otherwise, you will get a sky values. Okay. Let us save this. I am again going to copy this in Flume's conf directory. Okay. Now I have explained all these items, how to configure components, how to configure source, then channel, and finally the sync. Now it's time to start the Flume agent using this configuration file that we just created. After that, we will start Kafka console producer.sh so that we can pass our messages to the newly created topic that we use in exercise 2.conf. After that, we will check the same messages in HDFS. They will be generated by the name of topic itself. Finally, we will check the contents of the final file. Let us do it now. First of all, I need to start the Flume agent. Okay, this is the command exactly same that we were using earlier. I am using just exercise 2 here. Okay, and Flume agent will be started. It will get the configuration from exercise 2.conf file. Okay, meanwhile it is starting. Let me just prepare the Kafka producer as well. Okay, this is the command kafka-console-producer.sh. This is the script that will be present at Kafka bin directory. I will use the broker list. I am going to generate this messages on this particular broker itself, and the topic name is Kafka Flume in our case. I am going to generate some messages in this topic. Okay, from this side, Flume agent is completely ready to receive messages. So before I generate messages via producer, let me show you what this has done already. It has started the sync channel and all. Okay, so Okay, you can see here creating channel 1 type memory. We are using in memory channel. It has created that, created channel 1. Then it is creating the source 1, and the type is Kafka source. Okay, and after that it is creating the sink. The name of the sink is sink1 and the type is HDFS. So Flume agent has done all the settings. Now it's time to generate the messages. I am on Kafka console producer and I am going to type some messages which are going to store in Kafka Flume topic. This is my Kafka topics event. Let us see if the same message has been passed through in-memory channel and stored into HDFS. Let us check this on the console first. Okay, you can see, first of all, it will create a temp file for every message that is being updated in that topic, and then create the main data file with the name this. We have given this path that we want to store data in temp directory of HDFS, and the name of the directory where topic will store the data is Kafka-Flume, which is exactly same as the name of our topic. Then we choose that we want to store the data date wise. This is the date and this is the main data file. Let me generate 2 or 3 more messages and then we will close this and finally check the data in HDFS itself. This is my second message. This is my last message. We are all good. Cheers. Okay, so Flume agent is continuously writing all of these newly updated data into HDFS. You can simply see opening, renaming and writing. Writer callback called means writing to HDFS is complete. Similarly, it is doing for all the 5 messages that we recently generated in Kafka-Flume topic. Okay, now as we are done with the generating messages via Kafka producer, those producers messages have been passed through the in-memory channel of Flume and finally get stored into HDFS. Let us check these final results into HDFS itself. First of all, let us close the producer, then close the Flume agent as well, do JPS and kill the application that was running for Flume agent. Okay, now I'm going to do into HDFS hadoop fs-ls temp Kafka Flume. This was our topic name. Let us see what are the different directories that Flume created here. We wanted to store the data in via dates. I think I missed something. Okay, this was the name. Oh, I think I mistakenly given him Kafka here. So Flume has generated this directory. Okay. So now you can see do have multiple data files at this location. All the data that was generated via the Kafka console producers was continuously being stored at this location. Let us cat this data file. Okay, this is the first message that we generated, right? On the producer window you can see this is Kafka topic event. This is my Kafka topics event. You can see the same message here in this file. Similarly, you can check any of the files. So basically it will contain all the messages that we were generating in Kafka producer. So that is all with the integration part of Kafka with Flume, and here we were using Kafka as a source only.
Just a quick info guys, if you want to become a certified professional in Apache Kafka, then Intellipaat offers Apache Kafka certification and training course. For further details, you can check the description below. So this brings us to the end of this session. If you have any queries, do comment below, we'll reach out immediately. Thank you and see you again in the next session.